All right, so this is section 4.5. Although I'm not here right now, what I want you to make sure you're doing is make sure you get the notes just the way I do them on the board. If you need to go back, ask the instructor to go back just a little bit and make sure you copy correctly. We have a few definitions to start off with. Since we are going to be talking about triangles, we're going to start off with a triangle is scalene if and only if it has no equal sides. Now I know what some of you are thinking is that a scalene triangle is also a triangle that likes to climb mountains. Scalene triangle. There's no one here to laugh. Another type of triangle we'll be looking at is what's called a triangle is isosceles. If and only if it has at least two equal sides. Now the key here is the at least. It can have three equal sides and still be isosceles, but it has to have at least two equal sides to be considered isosceles. When we have the test on this, I'm going to be looking for the at least. Make sure you do that. Another type of triangle. A triangle is equilateral. A triangle is Apparently I misspelled part of this. Thank you for pointing that out. A triangle is equilateral if and only if it has all equal sides. Now, again, that means what? An equilateral triangle is isosceles, but not all isosceles triangles are equilateral. We also can classify triangles by their angles, starting with a triangle is obtuse if and only if it has an obtuse angle. Don't forget that means that the angle is greater than 90, less than 180.
I'm out here.
A triangle is acute if and only if it has all acute angles. Difference here between the obtuse and the acute is this. The obtuse only will have one obtuse angle. The other two angles will be acute. An acute triangle has all three of them being acute. They're also kind of cute to look at. Another kind of triangle that we've already talked about briefly, but is a right triangle. And a right triangle has one right angle. And finally, the last type of triangle that we're going to define today is an equiangular triangle. An equiangular triangle has all equal angles. An equilateral triangle is also equiangular, but we're going to actually prove that, and I'll show you that in just a moment. So for now, these are the basic terms we need to remember. Scalene triangle, Isosceles triangle, equilateral triangle, obtuse, acute, right, and equiangular. That leads us to our first theorem in section 4.5, which is theorem 9. And it says if two sides of a triangle are equal, then the angles opposite them are equal. Make very clear here, this is in a single triangle. So in a single triangle, if two sides are equal, then in that same triangle, the sides opposite them are equal. So what this is saying is, for example, if we have this triangle with two sides equal, so if UF is equal to UN, then we can see that the angles opposite those sides would also have to be equal. So then angle F equals angle N. Single triangle, focus on that. That's what most people make the mistakes on here. If it's in a single triangle, two sides equal, then the opposite angles are equal. Remember that, single triangle. You will be doing this in proof, I think, in this assignment, so you get a little bit of time to play with it. One thing I want you to think about too is if we also have, let's for example, a triangle like this, but in this case I have a segment going through the center. Okay? If I were to say still again, let's say GU is equal to MU, if this side is equal to this side, even though this forms two smaller triangles, there's still a bigger triangle here. So we could still kind of look at it as if this didn't exist in the middle, and it would still imply that these two angles would be the same. So we're still looking at a big triangle. Even if it has that split in the middle, it's still one large triangle. Again, you'll look at the proof of this in tonight's assignment. How about we do another proof? Or excuse me, another theorem. We'll move on to theorem 10, which is just the converse. Theorem 10 says, as opposed to if two sides are equal, then the angles opposite of them are equal. It says, if two angles, again in a single triangle, are equal in a triangle, then the sides opposite them are equal. Just the converse, just the reverse. So theorem 9, if you have two sides the same, then the opposite angles. Theorem 10, if you have two angles the same, then the opposite sides. Now with the definitions, we talked about the fact that equilateral and equiangular mean almost the same thing. And that's actually a corollary. Don't forget, a corollary is what? A corollary is a mini theorem. So corollaries can be on your theorem list. Corollary to theorem 9. Well, theorem 9 talks about sides. And so what it says is an equilateral triangle is equiangular. An equilateral triangle is equiangular. Meaning again, if a triangle has all equal sides, then it also has all equal angles. How about we prove this? Okay, still nobody here. All right. Well, let's look at this triangle. Let's say that this triangle is triangle BAT. And I'm going to say given is the triangle BAT is equilateral. I want to prove then that triangle BAT is equiangular. This is a corollary, so it's going to be a really easy proof, a very short proof. Start with our statement and our reason, our two columns. Start with our given as always, triangle BAT is equilateral. What does it mean for a triangle to be equilateral? It means it has three equal sides. So we're going to say that BA equals AT equals BT. Definition of equilateral. Well, Theorem 9 says that if you have two sides equal, the angles opposite them are equal. So let's look at the sides opposite these triangles, or these sides, the angles opposite these sides, excuse me. So we have BA and AT. So that would mean that B and T were equal by Theorem 9. We also have that AT and BT are equal, which would mean that A and B were the same. And this is by Theorem 9. Theorem 9 says if two sides are equal, the angles opposite those two sides are equal. But wait a second. So I have B is the same as T. I have A is the same as B. So that means what must be true about A and T? Well, if they're both equal to B, they have to be equal to each other. So we can say that angle B is equal to angle A, which is equal to angle T by substitution. But if all the angles are equal, then we have proved what we wanted to, which is triangle BAT is equiangular. Definition of equiangular. Don't forget to stop with our QED. Quo erat demonstratum, that which was to be proved. You're going to do a proof very similar to this, except I think it's going to be the proof of Theorem 10, corollary to Theorem 10, which I'll give you in a second. The difference is just going to be reversed. You're going to switch the order. Don't make it difficult. On that, let me give you the last corollary for today. Corollary to Theorem 10 says an equiangular triangle is equilateral. Same idea, just the reverse. Basically the same proof, just in the reverse order. And well, that's it for today. So the lesson for tonight, the assignment will be page 155, question number 32 to 34. For 35, you should use the distance formula, which you should have memorized by now. And then 36 to 38. It will also include one other page, page 159, 1 through 6, 12 to 13, and 18 to 21. The sub will be going over the answers to this, and you should be correcting them tomorrow when the sub goes over them. Any questions, remember, you can call me at home till 7 o'clock. Good luck. Thanks very much.